And hello, welcome to another video. I'm going to show you Sdl2, C++, Sdl2, and this one is DrawPixel. I polished up a better program for this. So this is the first test for DrawPixel. There's several ways of doing this. This is the first way that I will show you. 1024 by 768. You can see it is very slow, 2 frames per second. Yeah, it's DrawPixel. SDL render DrawPixel is very slow. You can see half a second, 2 frames if you're lucky. Okie dokie. I will go to the code, change it to 640/480. Save it. I want to show you all the code in a minute. I made a much better version of this, which you can copy. 640/480. Bit better, 5 frames per second. This is the reason why you should never use SDL render draw point. There are better ways. I will show you better ways later on, but at the moment, there we go, there's the draw point, and I will show you the code. So copy the code exactly. You need this for print line, you need this for the time because you use it for the random, and you need this SDL2. This is the compile line. Move to your folder. Compile line for Ubuntu works on mine. Compile line for Debian works on Raspberry Pi. Run it. This is instructions. I'm setting default. You set the screen width and height. You're going to use running. When this is on, it's running window renderer. I remember the window width and height. I'm keeping the current second. I calculate the current second by getting the ticks, dividing it by 1000 as your current second. Remember the last. When one changes, it will then click to the next one and process a process second. Remember the last frame time. How many frames? Keeps frames per second. Graphics. This is SDL startup. You give it a title. It just be char star with height. The normal SDL startup, create window, create renderer, and get the window size, which I store. Graphic cleanup, you need to clean up the rendering window and quit. I put 2 new routines in here at the moment, window width and window height. These are what I used. I might be able to eliminate these actually. Made a draw pixel routine with an SDL point and an SDL color. Yeah, because copy all this code, test draw pixel. This just draws up to the max colors, draws for the entire height of the canvas. You use, if it's less than, it will go up to the width, but less than one less than it. So less than or equal will give you right to the last pixel. This gives you right to the last pixel in width. Rand, the percent, it will give you this many combinations. So if you go 256, it will give you a number between 0 and 255. That's what you want. This, allocating these colors that are one at a time, because this is a UN8. One at a time is the only way to make this work. When I tried to put it all as one color at once, it didn't work. Right, start up. You need srand with the time. That's what we need, the time constant to start the seed generator. Do the start up. Width, height, doesn't work, return false. Fig calculates current second. Remembers it's the last second to do the same, so it doesn't activate the routine. Reset last frame of frames. Every second. Well, here's the main. Start, middle, end, clean up. Clean up just does graphics cleanup, which I showed you at the top. Middle, running. figure out what second we're in by dividing by 1000, then you put it into an int, so it should cut that down to an int, get rid of the floating point. If it's not the same as last second, then it processes the once a second. Here it takes the current second and stores it as last, so they're the same, and it won't trigger again. Stores the frames per second, and here every frame, at the end of the frame, it will add 1 to the new frames. It resets frames to 0 here, new frames to 0 here, increases the frame once here, and then when it ticks on the second, it will remember it as the frames per second, resets the counter to 0, and then it prints how many frames and what the last frame time was. So we've activated the process second here. Now get the start time before at the start of the frame, get the start time here. Process the inputs. If you click the top right corner X, it activates this and leaves. If you push the escape key, it activates this and leaves. Clears the screen to black here. Does the draw test pixel routine, which is here. Draws a box of the full width and the full height, and does every pixel with a random color. As you see, it's very slow. You probably don't want to use this unless you have to. There are other ways. I will show you other ways afterwards, and you'll get speed tests. This is the full program with speed test. Everything not needed is taken out. Draw it, clear it, draw it, and then present to flip it to screen. +1 frame. Remember to calculate last frame time by getting the current frame time and removing the start. And this is a uint. And that's it. It's very slow. There are other ways. I will show you all of them one by one. I just took all of the code and put it into one separate program. If you just take all of this and write it all out, pause the screen. Yup, that is Sdl C++ Sdl example on Windows 11 using WSL layer, and it's got loaded Ubuntu on mine. On mine, once you've done this one, you go to your folder. I've already gone to the folder here. Run the compile string. My one's the Ubuntu one here. Here. Like that. If you get no error, it worked. And now the execute command /execute. I'm doing all this in Linux. You can do it on any operating system, but I don't know how. I will try to do it Windows EXEs later. And then you get this. But you see that you are only getting 5 frames per second, not 64480. But now I've got the put pixel. Next will be line, but I will do a few more of these because there's about 3 different ways of doing this.